Hello everyone. Today we are going to find the member forces in this 3D truss. This is the x-axis, this is the z-axis, and this is the y-axis. First we need to find these reactions. In the y direction there is only one reaction so that we can easily find that. Let us apply this rule. Let us keep upwards as positive and downwards as negative. So this will be negative and this one will be positive. In this way, for AY, we will get 60 kilonewton. About the point A in the z-axis, let us take movement. Along the point A, we have to draw a line in the z direction. So it will be easy. We know that when we take movement in the z-axis, we should not take any load or reaction in the z direction. So this one we should not take, this one and this one we should not take. Also along this line, we should not take anything. So 60 kilonewton and AX we should not take. Now there is only two remaining, BX and 60 kilonewton. About this line, Bx is acting in the clockwise direction, so it will be positive and the distance is 6. So 6Bx. About this line, this load is acting in the clockwise direction, so it is also positive and the distance is 4. For Bx, we will get a negative value. That means the assumed direction is incorrect. This direction we need to change. You can see that I have changed the direction of Bx. Now let us apply this rule and find Ax. Let us keep this side as positive and the opposite side as negative. So this one will be negative and this one will be positive. For Ax, we will get 40 kilonewton. In the joint A, let us take moment in the y-axis. We have to draw a line in the y direction, so it will be easy for us. When we take movement in the y-axis, we should not consider any load or reaction in the y direction. So this one and this one we should not take. Also, we should not take anything along this line. So these two we should not take. This one and this one we should not take. Only one is remaining, that is CZ. If there is only one remaining, that will be equal to 0. Now about the point A, let us take movement in the x-axis. Along the point A, in the x direction, we have to draw a line. We know that when we take movement in the x-axis, we should not take any load or reaction in the x direction. So this one and this one we should not take. Also along this line, we should not take anything. So this one and this one we should not take. Only there is two remaining, BZ and 60 kilonewton. About this line, BZ is acting in the clockwise direction, so it will be positive. For BZ, this is the perpendicular distance, so 6BZ. The load 60 kilonewton is acting in the clockwise direction, so it is also positive and the distance is 8, so 60 into 8. For BZ, we will get a negative value. That means the assumed direction is incorrect. We have to change this direction. You can see that I have changed the direction. Let us apply this rule. Let us keep this side as positive and the opposite side as negative. So this one will be negative and this one will be positive. For AZ, we will get 80 kilonewton. We have to enter the coordinates. Let us keep the point A as the origin. So here x, y and z will be 0. From here we have to measure all of the distances and we need to make the coordinates. To find the member forces, we are going to use method of tension coefficients. This is the sign conversion in the x direction. This is for y direction and this is for the z direction. In the joint D, we can apply the rule sigma f z is equal to 0. The member CD is purely in the y direction and the member AD is purely in the x direction. So we can take only one member, that is DE. If there is only one member, that member force will be equal to 0. So FDE will be equal to 0. So this is 0. And then we can apply the rule sigma Fy is equal to 0. In the y direction, there is only one member, that is DC. We cannot take the member AD because it is purely in the x direction. In this case, FDC will be 0. This is 0 and this is 0. Then we can apply the rule sigma fx is equal to 0. There is only one member, so FAD also will become 0. Let us take the joint A. Let us apply this rule. When we apply this rule, we can keep the x direction as a reference. So here this is the line for us a reference. This side will be negative and this side it will be positive. The member AE in the positive side, so this term will be positive. No need to take the member AD because it is a zero force member. For the member AB and for the member AC, there is no distance in the Z direction. You can see that. So no need to take them as well. That is why I took only one member AE. Then we have to check if there is any load or reaction in the Z direction. There is a reaction in the Z direction, that is 80 kilonewton. It is acting this way, so it will be positive. Distance of AE in the Z direction is 8 minus 0, so it will be 8. For TAE, we will get minus 10 kilonewton per meter. Now in the joint A, let us apply this rule. No need to consider the member AB because it does not have distance in the x direction. Only we have to take the members AC and AE. We know that in the Z direction we have to draw a reference line like this. This side it will be negative and this side it will be positive. Both of the members are in the positive side, so both of these two terms should be positive. Then we have to check if there is any load or reaction in the x direction. There is a reaction in the x direction, that is 40 kilonewton. It is acting this way, so it will be positive. Distance of AC in the x direction is 8 minus 0, so it will be 8. And for AE, it is 4 minus 0, so it will be 4. Just before we have found TAE, let us apply that. For TAC, we will get a 0. Now in the joint A, let us apply this rule. For the member AE, there is no distance in the y direction, so no need to consider that. The members AD and AC are zero force members, so there is only one member remaining, that is the member AB. We have to only take that. If you take the joint A, the member AB is acting upwards, so this term should be taken as positive. There is a reaction 60 kilonewton in the y direction. It is acting upwards, so it will be positive. The distance of AB in the y direction is 6 minus 0, so it will be 6. For TAB, we will get minus 10 kilonewton per meter. Let us take the joint C. In the joint C, let us apply the rule sigma Fy is equal to 0. This member we cannot take because it is purely in the x direction. So only one member we can take, that is the member CE. We know that if there is only one member, that will be 0. So FCE will be 0. Now we can apply the rule sigma Fx is equal to 0. There is only one member, that is CB. So FCB also will be 0. Now let us take the joint E. In this joint, let us apply this rule. No need to consider AE because it does not have distance in the y direction. So only we have to take the member BE. When we take the joint E, the member BE will be acting upwards. So this term should be applied as positive. And there is a load in the y direction. It is acting downwards, so it will be negative. The distance of BE in the y direction is 6 minus 0, so it will be 6. For TBE, we will get 10 kilonewton per meter. Some of the lengths are given in the question. Length of BC and length of AD is 8, and length of AB and length of DC is 6. The rest of them here I have found. We have to make a table. In the table, first we have to enter all of the members, then the tension coefficients, then the lengths. We have to multiply the tension coefficient with the length so that we will get the forces. If the force is positive, that will be tensile, and if the force is negative, that will be compressive. Now we are going to end this session. Thank you for watching this video.